So this is part one of a review of simple algebra. And so the first one, it says find the product. To find the product, we have three terms here. We have the first term is here, the second term is here, and the third factor, is here. So we have three factors to multiply together. So we have choices here. You can multiply them in any order that you want, but I'm going to choose to multiply the two parentheses together first, and then I will multiply the two by whatever answer I get from multiplying the two parentheses together. So 10x times 4 is 40x. 10x times a negative 2x is negative 20x squared. Negative 3 times a positive 4, negative 12. And the negative 3 times the negative 2x is positive 6x, right? Okay. And do I have a 40 and a 6 I can put together in there? So I wonder if I can do this. If I can move this down. I think I can. Oh, look at that. Isn't that cool? Give myself a little bit more space. So if I put the 40 and the 6 together, I end up with the 2 multiplied by 46x. Do you see where the 6 and the 40 were? Now, I'm going to actually write this in order. I'm going to write it with the x squared first, because we're so used to seeing the x squared part first. I'm going to write the negative 20x squared first. Then I'm going to write the 46x. 46x, because we have 40x's plus 6 more. Then I'm going to write the negative 12 at the end. And I have 2 that I have to still multiply by all of that. So I'm going to end up with negative 40x squared plus 46x times 2 is 98. 92x, 92 plus 92x, 92, you can read that, minus 12 times 2 is 24. 24, kind of small there, I hope you can read it. That is your answer. I could highlight it or something like that maybe, right? If I can, on black. I don't think highlight's very nice, okay? All right, next one is simple one, a minus x times a minus x, because that's what that really means, right? A minus x times a minus x. Oh, that's a 2. My bad. Look like an A. 2 minus x. 2 minus x. Boom, 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 boom. So it looks like I could say 2 times 2 is 4. 2 times a negative x is a negative 2x. And on the inside, that's these two, right? I did this times this. I did this times this. And now I'm going to do this times this. And then this times this, right? So the next one is 4 minus 2x. The inside, the negative x times 2 is minus 2x again. Negative x times 2 is negative 2x. And the last one is negative x times negative x, which is positive. Negative times a negative is a positive. Positive x times x is x squared, right? So the way I would write this would be the x squared in the front. That's the way we have to write it. Negative 2 is negative 4. If I put them together, you add like terms. Negative 2x, take away 2 more x is negative 4x. And then I have the positive 4, which was at the beginning. Positive 4. And that is my answer. Can I highlight it a different color? Is that going to work better? Maybe. The green. Okay. Boom. All right. Next order of business is to make myself the space. I don't know if I need to. This one here says factor. The directions say to factor. To factor means kind of like dividing out pieces from every term. First, you have to know that what I've got here is 3 terms. One term and it's separated by a plus or a minus sign. So I got one term, then a minus sign, another term, then a plus sign, then a third term. There are three terms here, three pieces, okay? And they're separated by plus or minus signs. So this is called the trinomial. And you should probably know that this is a trinomial. If it's only two pieces, it's a binomial. This piece has one term and another term. This binomial has obviously two terms. It's a binomial. But it also, this term has several factors, 2 and an x and another x. It has three factors here, three things multiplied together. Okay, x and a 2 and another x. All right, so let's take a look at this trinomial, this first one. So to factor it, the trinomial, the most basic trinomial, you basically are undoing a multiplication. So you have this factoring, this FOIL that somebody did to this thing, or whatever you want to call it, multiplying things together, and now we're going to undo it. So what times what? Well, let's look at the first part first. So I'm looking at the I'm looking at the x squared part first, and I'm going to be putting a number here and here. What two numbers am I going to put here and here, or what two things, when I multiply them together, like we did back up there when we multiplied, back up here when we multiplied the first times the first? When we multiply this first times the first times the first, if we go backwards to see what we get really was from this, we should have an x and an x here, because x times x will give us x squared. And you should already know that. Okay, x times x gives us x squared. Okay, and then to get the other numbers, okay, we need to think about what two numbers am I going to put here and here. It's going to be no x's. It's just going to be a couple of numbers. And those numbers have to be so that when I multiply them, I get a positive 6. And then now several different numbers will give me a 6. 1 times 6 is 6. 2 times 3 is 6. -2 times -3 is 6. So there's lots of choices. But the ones that really will work for me are the ones that are going to add up to -5. So the way we always did this was make a little table and do like 2 times 3. And you should be able to do these in your head pretty soon if you can't already. -2 times -3, 1 times 6, -1 times -6. All those will give me a positive 6 when I multiply them together. Which one gives me -5 when I add them together? And yes, you guessed it, these two. -2 and a -3. So that's what I'm going to put here. And that's my answer. And you can check it by multiplying it, those two parentheses back out, or you should get the top. Okay? The next one we will do in a few minutes. Okay, so we are now looking at number 4. And before we begin to factor things out of a trinomial, remember that we call this a trinomial because there's 3 pieces to it, right? This first piece, the second piece, and the third piece. Before we factor using this method here, before we do that, let's see if there's a common factor. What does it mean, a common factor? So, what I notice when I look at the 3 pieces is 12, 60, or -60, and 72 are all multiples of 12. So it appears that I can just divide 12 out of all of these numbers, which is factoring the 12 out. So when I divide the 12 out or factor the 12 out, I would put the 12 in the front, and then I would make the parenthesis like this to see what's left over inside. So 12 times what gives me an answer of 12x squared? Well, 12 times x squared is equal to 12x squared. 12 times something gives me -60. So I would say 12 times 5, -5 is, and I had an x there, put the x where it belongs. Yeah, 12 times -5 is -60. And the last one, 12 times 6, I think, is 72, right? Okay, then, oh, gosh, look at number 3. Problem number 3 again. Does something look familiar? Oh, so I can continue to factor that, and I must continue to factor it. Let's try something here. Let me see if this works. Boom. Maybe. Doesn't seem to wanna. It's too close. I wanted to move just that little piece there. Maybe. Oh, look at that. It's gonna let me. Yeah? Isn't that cool? All right. So, back to my... So, I can continue. I have the 12. And I'm gonna make the 2 parentheses, like unfoiling this thing. And I'm gonna just copy, look at problem 3 again. X minus 2 and x plus 3. And x plus 3. And that's completely factored. We can't factor it anymore. Just like, if you look here on the left, I'll point you in the direction, I guess, of over here, and I'll do something here for you, okay? If you look there, you could see if I had a number like, say, 24. Remember that we could factor the 24 by getting smaller numbers, so it's like 2 times 12, and the 12 can continue with 2 times 6, and the 6 can continue with 2 times 3. Remember that all these were the basic factors, the 2's and the 3's, the prime numbers were the basic factors of 24. Well, these are the prime factors, back over here, these are the prime factors of the 3 factors here of the original problem. I could break the 12 down into 2 times 2 times 3, but we don't do that, so we just put it there. But the other 2 are definitely prime, the x minus 2 and the x plus 3. This has common factor. I think 2 is a common factor on problem number 5, so I'll divide the 2 out, or factor the 2 out. Let's make it look nicer. 2. And what's left over is x squared plus 3. Something that comes to my mind right now that I'm going to do down here for you, okay? Something that comes to my mind right now is, what if you had, now you have 2x plus 3. What if you had this, 2x minus 3? What if the original problem was 2x squared minus 6? So we would factor it into 2 times x squared, or x minus 3. I should say, 2x times x minus 3, right? I guess what I was thinking was... Oh, I can't do the x out of there. Yeah, it's just 2 times x minus 3. So that's the same thing, right? 2x squared right there. Okay, yeah. So I have that. What about... And that's finished. We can't do anything else with that. But a different problem, if I had this, that's one that you might remember from last year, that if you have a final answer that looks like that, there's a problem. It shouldn't be your final answer, because you could continue that one because you have a difference of 2 squares. This is a really special case that you learned in Algebra 1, where you take the x's, and here you have plus 2, minus 2, okay? And that would be the final answer if I give you, say, 2x squared minus 8, right, as an original problem. This would be, you would do this for step 1, and then you would do this for step 2. Okay, and why can you continue to factor that? Because you have a minus sign, and you have a square, x squared, and you have a square, 2 squared. The 4 is actually 2 squared. So if you have x squared minus 2 squared, you'd have x plus 2, x minus 2. And check it out. Go ahead and factor it out, and you can see that it should be multiplying and give you the right answer, because some of the stuff will cancel away or go away. Okay, back over here. So much easier. So let's get the 2 out of there on number 6, problem 6. And I think there's an x in both terms. So we can divide the x out. What's left over? I have another x, and I have a plus, and I have a 3. Now double check it. What's 2x times x? Yes, it's 2x squared. What's 2x times a positive 3? Yes, it's 6x. So you factored it. Excellent. Good job, everybody. And see if you can do this one. Pause the video and try it. So this is going to be 6. And what's left over? Well, in the second part, I've got 6 times 4 is 24. So I've got that. In the first part, I've got 6 times 1. Right? Which would be my 6. And that's finished. This one, I've got a 7. I could factor out a 7. Could factor out negative 7 if I wanted. Okay? But I'm going to just try well, let's try that. Why not? I'm going to factor out a negative 7 and see what happens. And also, in both, you have a x squared. There's an x squared in the first one. And there's an x squared in the second one. Let's see what's left over. So negative 7x squared times 1 would give me negative 7x squared. And then I have a plus sign. And negative 7x times what is going to give me this part? 3? Negative 3? So it's going to actually be a negative. And I have 3. And what am I going to put beside the 3? You should know that there's another x, because x times the x squared on the outside would give me the answer, would equal the x cubed. Okay, so that's done. I think I got a 9 here, or a negative 9, whatever you want to do for it. I'm going to just say, in this case, we can just do 9. I don't care if you do the negative or not. And 1x can come out, because I have x times x in here, xx, and I have 1x over here. So all of it, everything has 1x. So I'm going to take out 1x, or divide it out, okay? And then I'm going to have some stuff left over. I think I have a y also here. Okay, so I can take a y out. I have one y in the first term, and y times y times y in the... So I'm going to take out and divide out one of the y's. And what's left over in the first part? There's still an x, because x times x will give me the x squared. And there's a negative, and that's it, right? Okay, it multiplies together to give you the right thing. And then this one here is a plus, and I think 3 times 9 is 27. Well, let's make a nicer 3. 3 times 9 is 27. I got an x is gone. We took the x out, and we took one of the y's out, or we factored out one of the y's, so we put it in the front. So I have y squared left. Okay. This one has an x in everything, so I'm going to divide out the common factors first. And then I've got a couple of x's multiplied together here inside, an x squared. And I have a minus 5, and I have one of the x's, because there's already an x on the outside. So x times negative 5x is negative 5x squared. And then I have plus 6. Oh, wait a minute. That looks familiar. Why is Mr. Bushy doing this to me? He's crazy. Why is he doing this? We can continue to factor. And you already know now this one has a negative 2 and a negative 3. And it doesn't matter which one you put first or second. Double check that you understand that it multiplies together. Now, the rules of the exponents, we can, when we have a parenthesis with an exponent on the outside and some exponent on the inside, then that's the same thing as the base. M is called the base because it's on base is down low. It's on the bottom. So the base, and 2 times 3 or 3 times 2 is 6. Okay? It's kind of like M3 times M3. M to the third, M cubed times M cubed. And that answer to that is m to the 6th power, because you add together the exponents, the 3's. Okay? So that's this one, m to the 6th. Oh, but what if you had two things in there? Like here we have a 3. Look at number 11. Here we have a 3 and an x squared. So that means that you got to distribute this 2 with that one and with the 1. That's a 1, right, guys? Because it's 3 to the 1 power. It's always to the 1 power. We just don't usually write the 1, right? It's 3. So I'm going to end up with 3 squared times x to the 2 times 2 is 4. So this is going to be 9, the final answer, x to the 4th. Boom. And this one has a 3 going with both of these. It's got to distribute because there's a parentheses. All right. So I've got a negative 3 to the 3rd power. So that means negative 3 times negative 3 times negative 3, which is positive, or which is negative, because it's an odd number of negatives. 3 times 3 times 3 is 27, right? 9 times 3. And then we have x to the 6th. And that's your answer for this one. That's supposed to be a 6. Okay. So 3 goes with the 2. We have 2 cubed, which is 2 times 2 times 2. That's 8. And then we have the x to the negative 1 to the 3rd. So the 3 multiplies with the negative 1, which is x to the 3 times negative 1 is negative 3. And then we have the y with the negative 2 times 3 is negative 6. Okay? And depending on directions, you might be told we don't want to leave negative exponents. I probably don't want you to leave negative exponents in the final answer. So what you need to know is when you have negative exponents up top and you can't have them, you're going to do this to change them. You're going to, oh, that's a nice color, huh? You're going to take the 8 and leave it where it is, because the 8 didn't have any negative exponents or anything. But the x had a negative 3 on there. I'm going to make a fraction. I'm going to put the x down here and make it a positive 3. Same thing with the y. Y's got a negative 6 on top, because you think about this like the top of a fraction, okay? There's a 1 on the bottom of all those numbers, right? So you can put the y to the negative 6 on the bottom, make it a y6, okay? And then, boom, you got it. All right, guys? That would be your answer for number 13. Okay? Let's stick with the same color. Number 14, anything to the 0 power is equal to 1. Anytime you have a 0 power, that whole parenthesis is to the 0 power. So that whole thing is equal to 1. That's it. See, I can make this easy for you. On this one, negative 5 over 10 simplifies to negative 1 over 2. And I have other stuff on top and other stuff on the bottom. Let me make it a little neater, maybe. I'm not able to. Okay. All right, so negative 1 over 2. And I have x2 on top and x1 on the bottom. That's kind of like, look over here for a minute. That's kind of like we have x times x on top and an x on the bottom. One of those x's can cancel out or divide out. So we have just an x left over, okay? And that gives me my just x to the 1 on top of the fraction on the top. So if you look back over here again at the fraction, you have x squared on top and x to the 1 on the bottom. It's kind of like you have an extra x on the top than you do on the bottom. So one of the bottom one will cancel with one of the top ones, and you have an extra leftover on top. So write it here. The extra leftover x is on top, right? And with the y's, you have a y cubed and a y squared. So you have an extra y on the top. It's like y, y, y. And on the bottom, you have y, y. 2 on the bottom, cancel with 2 on the top. You have an extra 1 on the top. So I'm basically done with that. Okay? You should know from Algebra 1 that you could write that in different ways, but you could write it like 1 - 1/2 x y, and you need to know that that xy is kind of like on top of a fraction. It doesn't really go with the 2. It goes up with the 1 on the -1/2. Okay, guys? So these are things that you were exposed to in Algebra 1, whether you remember it or not. Okay? This one has a -10/2, which is on top -5, right? And then we have extra x's on the bottom. There are 3 more x's on the bottom than there are on the top. So that top one's going to cancel with one of the 4 on the bottom. We just get 3 extras on the bottom. Remember, one of those bottom ones canceled with the top x. Same thing with the y's. We have y squared on top, y5 on the bottom. Well, the y squared, the 2 y's multiplied on top, are going to cancel off with 2 of those 5 y's on the bottom. So instead of, there won't be any y's left on top, but the extra ones on the bottom are y cubed. Okay? So there's your final answer. -5 over x cubed y cubed. Couple more. When you see that, all right, so remember that we said that when we have a power, like say m to the -2, it's the same thing, or you might not remember, but it's the same thing as 1 over m to the 2. Okay? So you need to kind of remember this rule of exponents. You can look it up if you need to, but it's one of the rules to remember that when you have a negative exponent, it's 1 over the positive exponent. Negative a to the negative, let me say, a to the -5 is the same thing as 1 over a to the 5th power. And you're going to use that a lot. Okay? So when we have a negative power, even on the bottom, if I had a x to the -3, okay, on the bottom, it's the same thing as, you could say that it's the same thing as 1 over x to the +3. And we had that on the bottom of another fraction. So we could flip it. And you're going to, basically, if you want to not remember all of the stuff, you just end up with x to the 1 power, which is the same thing as just x. So you change the sign of the power when you bring it up on top of the fraction, or when you bring it down to the bottom of the fraction, you change the sign. For number 18, the rule you might want to remember is if you have some same exponent, like AA, and you had some number like, say, m and n, that this is the same thing as a to the m minus n. That's the rule you remembered. Well, you did remember at one point. You subtract them. You subtract the exponents. So if you had, 3 to the 4th power over 3 to the 3rd power, you'd have 3 to the 4 minus 3. 4 take away 3 is 1 power. Okay? So you subtracted those exponents. I hope that helps you guys a lot. I know this is a long video, so a lot to digest. But it was a long year last year, or whenever you had this.